Hello everyone, in this video we will see what do you mean by Playfair Cipher and its examples. The Playfair Cipher, it is also called as a Playfair Square. It is called as a symmetric encryption techniques. We are using same key for encryption as well as decryption. It is a kind of substitution cipher technique and this was invented by Charles Wheatstone in 1854, but this technique was promoted by Lord Playfair. That's why it is called as a Playfair cipher. The term is also known as a Playfair square because it consists of 5 by 5 matrix of square will be generated while calculating the plain text to ciphertext as well as ciphertext to plain text. That's why it is called as a Playfair square. That technique is used in the World War I as well as in the World War II. Suppose in the given example, the key is given that is simple, SIMPLE. So how the letters will be placed in the 5 by 5 matrix? In our alphabets, total 26 characters are there, 26 alphabets are there from A to Z. But whenever we are calculating it by 5 matrix, that time we have only 25 blocks. So how the characters will be placed in the 5 by 5 matrix? So according to the Playfair scientist, our I and J letter will be placed in only one place. So that's why our 26 characters will be placed in the block of 25. So see in the example the key is given that is simple SIMPLE. So first of all we need to put the key in the 5 by 5 matrix that is S, then I, then M, then P, L and E. And the remaining characters other than simple keyword we are writing it from A onwards. So whatever the characters are already present in the key that is simple that are excluded in the next bit. So from A, then next one is B, then C, then D is there. E is already done in the keyword simple. Then we will go with the F, then G, then H. I is also already done. Then the next character is K. Then L is also already done. Then our next character is N. And likewise, we are writing all the characters that are excluding from our keyword. That is simple. So first of all, we have to put the key that is given in the example in our 5 by 5 matrix. And the second step is we have to add the characters that are excluded from the key in our 5 by 5 matrix. So our matrix will be generated. There are some rules and regulations for calculating our plain text to ciphertext. The first one is we are accepting only 25 alphabets. So I and J we will put in the one block. It is incompatible with the character that the number. We are not taking the number as a plain text. Only capital and lowercase letters are accepted. Special characters like spaces, new lines, punctuation marks that are not allowed in the plain text to ciphertext as well as whenever we are converting it into ciphertext to plain text. There are some other rules. The first one is if the two letters are in the same pair, then we have to add a bogus characters. So what's the rule says? Suppose the given plain text is happy, which consists of characters that is HAPPY. According to the Playfair cipher, first of all, we have to take a group of two characters. Suppose we are taking a group of two characters, then in the first group, which consists of H and A, and whenever we are taking the second group, then it also consists of P and P. So the P and P, these are the same character that are considered in the one pair. But according to the Playfair cipher rule, we cannot take the same letter in our one group. So that we have to add one bogus character into the first plain text. So the next one, our plaintext grouping will be HA will be in the one group, P will be in the second group. We are adding this bogus character that is X, and then our next group is P and Y. So we are dividing our plaintext into three blocks. The next one is second rule is if number of characters in the plaintext are odd, then add one bogus character at the end. So consider that our plaintext is pain is our plaintext. According to the rule, we have to take a group of two characters in the one block. So first of all, P and E, it is in the one block, and N is the single character that is remaining in the last block. That's why we have to add one bogus character at the end. That is our second group. So as per this rule, we have to convert our plain text to ciphertext. So what's the rules? We are again revising it. The first rule is if two letters are in the same pair, then we need to add one bogus character in our grouping. And in the second rule, if odd number of characters are present in the group, suppose the given example is pain, it consists of three characters. That's why we have to add one bogus character at the end. So these are the another rules for encryption. The first one is, rule number one is, if a pair of letters appears in the same row, then we have to take the next character that is immediate to its right character. If no letter to the right, then the first letter in the same row will be considered as the right character. That is our rule number one. Rule number two is says that if pair of letters are appears in the same column, then we have to replace immediately below the characters with the them. If there is no letter below, then wrap around to the top of the same column. And the third rule is if both the letters are there in the same row and the same column, then the two square corners will be taken for converting our plain text to ciphertext. Now we will solve an example, then you will be more clear about these three rules. In case of decryption, we are following the reverse rule of the encryption. So in case of rule number one, we are taking the right character of the plain text, and in case of decryption, we are taking the left character of our ciphertext. In case of rule number two, we are taking the below characters from that our plain text, but in case of decryption, we are taking the above characters, immediate above characters from our ciphertext. And the rule 3 is same as for the encryption.